This is a demonstration of the Neslab Thermoflex 3500 air-cooled recirculating chiller. It has a digital controller with user interface for ease of operation. It has a temperature range of between +5 to +40 degrees C and a cooling capacity of 3,500 watts at 20 degrees C. The reservoir volume is 1.9 gallons and it is powered by 208 volts AC single phase. First, let's just take a walk around the back. So your main power plug. This is the main switch to turn on the unit. The controller can be turned on separately, but this puts power to the unit. This is the water out, and this is water in. Now, this chiller is rated for a maximum capacity of 4 gallons per minute at 60 psi. This system will do that. However, for safety purposes, there is a bypass valve on here that is rated 10 to 50 psi. What that means is if the pressure of the application should exceed 50 psi, this valve will open. This is a standard installation that is on most of these chillers. In any case, this is again the output and this is the input. Very simple. Now we'll go around to the front and we'll start it up. First we'll toggle our switch on. Now presently we have the system set for 20 degrees C. What I'm going to do is I'm going to change the set point. If you push mode once, you'll see that it'll say SP, which is for set point, and then you can either toggle up or toggle down. So we're going to go down all the way to the minimum temperature. And it's still blinking, so then you would hit enter. And now very shortly this will start to cool down to its lowest temperature of 5 degrees C. So we'll come back in a few minutes and see how it does. Okay, we're back now, and we're almost down to our 5 degrees C mark. What we'll do is we'll check our temperature here. Wow, we're right on the mark. And we're down to 5.4, this says 4.9, so we're well within the range of 5 degrees C. Now the next thing we're going to do is we're going to go up to its maximum temperature of 40 degrees C. So once again, we'll change our set point. We'll raise it up. There you go. And we will enter. And this takes substantially longer than cooling down, but it shouldn't be too bad. That buzzer you just heard was very good. That's our low temperature alarm. Once it hits our lowest temperature of 5, that this will go out once it starts heating up, and it's starting to heat up now. So we'll come back in a little bit and see how we're doing at our higher temperature. we've returned. We've hit our high temperature. It shows a reading of 40.3, and the high temperature alarm has worked. As you can see, it says high T. When we were down to 5 degrees, it said low T, so those two safety precautions are working correctly. We show 39.8, so that's pretty close. Now what we're going to do is we're going to go back down to room temperature. There, one more. And we enter. Now we're going to come back down to room temperature. And when we get back down to room temperature, we're going to be using our load tester here. Now, I'll turn this on. What this allows us to do is simulate the load for each of the chillers that we test. Again, this particular unit is 3,500 watts. So once we get down to 20 degrees, we will turn the power up on here and we will adjust this to 3,500 watts. Typically, we let that run for a couple of hours to make sure that the cooling capacity can handle the load. And when we get back down to 20 degrees, we'll take a look at it. We're now at 20 degrees C, room temperature. We're going to come over to our load and we're going to turn this up. To approximately 3,500 watts. And we will come back later this afternoon and see how it's doing. Okay, we're back here. It's been a few hours, and as you can see, it has been holding 20 degrees very well. Let's check our watt meter, and we're still at 3,500. So that worked out well. We'll turn this down. And there's the only other thing I'd like to show you folks is that, again, I had mentioned earlier about this being a 10 to 50 psi bypass valve, which actually acts as a safety valve too. For example, if your application is something where valves open and close and actually restrict the entire water flow as to not damage the chiller, this would open up at 50 psi and allow it to flow. In any case though, we're going to step back here and we're going to take a look at this, and what I'm going to do is I'm going to bring this up. Here's 40, and as you can see, we're getting near the valve. Now there's 50, and as you can see, it's starting to drop. In any case, again, if you were to remove this, you could run this thing up much higher than 60, but it's not recommended. You can change these valves if need be, but presently this system runs very well up to 50 psi. And that completes this demonstration.